afternoon. Can the persons online tell me if you can hear me, please? Is that me? Can the persons online tell me if you can hear me, please?
I can hear you.
All right, I'll go ahead and start. All right, good afternoon, everyone. My name is Mrs. Asha Ford, and I'm going to be your lecturer for Prelim Mathematics, or ECON 0101. I'm not sure if you would have got any time to see, but if you look online, I've posted the course outline for you, as well as Unit 1. If you can, you can access it here if you want to, on your phone or tablets or whatever, if you have it. So I'm just going to go over the course outline, but before I do that, to those online, I'll just ask you that if you have a question, um, feel free to interrupt me because I might not necessarily be able to see if you post questions in the chat. And for anyone who's here, feel free to interrupt me. Also, just raise your hand and we can go from there. So the main objective of this course is to give students a clear understanding of mathematical concepts which are necessary for proper management of a course in mathematics. There's not much rigor with regard to proofs, but the main practical applications are used to reinforce fundamental concepts. In this course, the student is required to cover all the algebra and arithmetic of the CSEC syllabus. And students who have not done mathematics in a long time or who are very weak at mathematics should find this course helpful. So I've listed for you the 3 units that we're going to be completing. Today we're going to start obviously with Unit 1, and the only other information, you can read through this yourself, but you'll see we'll follow it in the course information. And the assessment, what I can tell you is that it's going to be online, but I cannot tell you the actual method by which we will be assessing you or how you're going to be assessed because it's awaiting approval. What I will tell you is that more than likely, you would have to make sure that you keep up with this course, and you have to make sure you understand the material because the exam might be a bit harder than normal because you're going to be at home. You're going to have access to all of your material, and therefore I have to test your understanding. So I'm going to switch over to Unit 1. This is already on your e-learning for you. And I'm just going to be going through what is here, but I know that most people prefer to see math written, so I'm going to be doing that today. So I'm going to go through these examples step by step. But just to let you know, you don't necessarily have to write everything that I write because it's already on e-learning for you, but it's your choice. Good. So we're starting with simplifying real numbers. Anybody has any questions for me before I begin? No? Good. Right, so we're starting with simplifying real numbers. Everybody can see the screen well? Right. Right, so when you're adding 2 like terms, this is just regular addition. We already know that the first example, which has that 7 plus 8 is 15, we already know that with positive numbers, if you have to add them, you just simply add them. Where people get a little bit confused is with negative numbers. Now, if the negative numbers both have a negative sign, in this case, -4 and -5, all you need to do is to put back that negative sign and add together the numbers. So, in any given case, If I take any number, let's say I have negative 2, sorry, and I'm taking it away 3, it's the same thing as if I'm adding those numbers together, but I'm putting back the negative sign, so the answer will be negative 5. If I had to take negative 10, subtract 1, when I say both of them have the same sign, sorry, I mean this has a negative sign and this has a negative sign. So I will put them together, add them together, and put back my negative sign. So that's simple. Now, when it comes to, hold on a second. When it comes to numbers that have different signs, so for instance, if I have negative 2 plus 3, what you are supposed to do is that you are supposed to put back the sign of the bigger number, but subtract the two numbers together. So what you're going to do is, in this case, the bigger number is 3. I'm going to put back that sign. And the numbers that I have, I'm going to take them away from each other, right? Or you can put 3 minus 2. It doesn't make a difference. Your answer in this case would be positive 1. Everybody's good with that? Okay. So let me clear this. Going back to the course outline, sorry, to the unit 1. So you have an example of that here in B. If you have, we have here negative 6 plus 2, put back the sign in the bigger number, which is the 6. So you put back a negative sign, and then you just subtract the numbers. I have here 9 minus 6, put back the sign in the bigger number. So that, sorry, that's a good one. This is an obvious question. Sometimes people get confused, especially when they bring a lot of questions together. If you don't see a sign in front of a number like this, it is a positive number. So your answer will have a positive sign, and you will just take them away as normal. So your answer will be positive 3. I'll go over one more example. If you have, let's say, negative 10, and let's say plus 2, again, put back the sign in negative number and just subtract those two numbers and get your answer. All right, can I move on? We're good? Just one person to tell me that we're okay. Any people online? The people online, are you good with this?
Yes, sir. Good. Thank you.
Great. All right, so moving along. You can extend this process to expressions made up of more than 2 terms. So for example here, I'm looking here. We have 3 plus 7 plus 4, which is obviously 14 because they're all positive numbers. But then you also have this question here. So what you would need to do is collect all the negative terms and collect all the positive terms and then follow along with the same method that I said before. So you have the negative terms in this case will be negative 4, negative 7, and negative 2. So if you see here, I put my negative outside, which is here, and I collect those 3 numbers together. And then I put the positive numbers together, which should be this group here. And I put my plus sign outside and I collect those numbers together. Now remember the rule that I said in terms of the negative numbers is that once they all have the same sign, once they're all negative numbers, you're subtracting together, then all you would need to do is to add them together. So that's what I do here. I add those numbers together to get 13, which is here. And then the positive numbers, I add them together as well to get 17. The negative in there comes from the negative sign that I would have put here. And my answer then just becomes 4. So we're going to do another example like that. Let's say I give you negative 6 plus 5 minus 2 plus 8 minus 3. So your first step, as I said just now, would be, and these examples obviously that I'm doing as I go will not be on your course outline. It will just be exactly what you see on the board. So you will do exactly what I said just now. You will collect your negative numbers, which are -6, -2, -3. Put your negative sign and just add them together. 6 plus 3 plus 2. Order doesn't necessarily matter. And then I'm going to collect the positive numbers, which in this case would be my 5 and my 8. So I'll just have a positive 5 plus 8. 5 plus 8 is going to give me 13. And then I will have to take away 6 and 3 is 9, and 2 is 11. And my answer is 2. So I'm going to give you just one quickly just to see if you understand, and just try to work it on your own, and I'll work it along with you. So try this one for me, please. Let me change this to black. Try that one on your own. Now, just to give you some information as you're doing this about the structure of the course, take it good. Thank you. You're going to have a practical component. It will not start this week. It will start next week, but you will be doing things like this where you'll be getting questions to do. Your tutorials will also start next week. Tutorials will not start in the first week. For those in the chat, just remember that I said I can't see, especially when I'm sharing my screen. I will not be able to see what you're saying in the chat, so just put on your mic and feel free to interrupt me if you have any questions. So those 11 chats, I have no idea what they are. 11 messages, sorry. All right, so some of us look like if we're finished. So you will collect all your negative terms, your -2, -8, -5. So you should have a negative outside of your bracket, 2 plus 8 plus 5. It's also fine if you would have put it over here. Doesn't make a difference. And then you are going to collect your positive terms. So let me stick with 1. It doesn't really matter whether you put it at the beginning or at the end. Actually, let me leave that at the beginning. So we had -2 plus 8 plus 5. And then the positive numbers, I have to put a positive sign here, and I have 7 plus 3 plus 6. For the first one, 2 plus 8 is 10, and 5 is 15. So you should have a -15 plus a positive 16. Now, some of you might have gotten this instead. Same thing, doesn't make a difference. This answer is 1. This answer here is also 1, because remember I said to you, if this one here is also 1. Remember I said that as long as these signs are different, you just subtract and put the sign in the bigger number. The sign in the bigger number in this case would have been positive for positive 16. And your answer would just be 1. Positive 1, the plus 1 and 1 is the same thing. Are we good with that? Can I move on? People looking at me a little bit.
Yes, please.
Yes, please, we are good.
Okay, so online people are good. So people here that's sitting at me looking like they're kind of lost. I'm not intending to lose you. So if you have questions, I have no problem answering. Are we good or are we lost? Good? All right. Now, I used to teach at a secondary school, so I know what students' faces look like when they have absolutely no idea what I'm talking about. All right, so moving along, we have another example here with decimal numbers. And by the way, there's, from what I see so far, I'm inquiring about it to ask, but there's absolutely nothing stopping you from using a calculator to do your negative or positive numbers. Your calculator should have a button that either looks like this at the bottom or looks like this, one or the other, and you're free to use that to put, you could put that entire equation in and just use the negative signs instead, or use it, you can use the plus or the minus, but if it's specifically a negative number, you will use these symbols. All right, so in terms of the last one that we're going to, this one that we're going to do, you can trade, those of you who have calculators, you can trade this with your calculator, see if you get the same thing. You can try example 2, which should be this one. This one here. On this one, you could just use the subtraction sign on your calculator. But if you're going to do it manually, you'll do that as well. But you can just try it on your own. Right. And that should be pretty simple, so I'm not going to sit there. Now, this particular part, this is actually pretty important in terms of how to add how to add decimal numbers. We must remember that place values are important. And when you're adding together decimal numbers, if by chance, I don't believe that you will. From what I see, from what the course was last year, and I can only go based on what was there because this is my first time teaching it, there's nothing that prohibits you from using a calculator, so I don't think it's necessary. But what I will say is that if you are asked to add decimal numbers and you have a component which is without calculators, just make sure that you line them up. So you have your 0.3 and 0.02, sorry, 0.2. And that's how they get the 0.32. This, you need to put a placeholder there and then just add going across, but I'm sure that we know that from primary school. And we can move on. The bottom one was just to understand what I was explaining to you in terms of putting together the negative and the positive numbers. This 0.9 that is here, just know that that is the same thing. 0.9 is the same thing as 0.9, right? Whether the 0 is there or not. So we move on to number 3. We have that like terms are terms which differ only by their coefficients. Note the coefficients can be the same. Now the coefficient is the number that is attached to the letters, basically. So I have here 3abc squared, 8bac, b squared ac, and cab squared. They are all like terms. If I write them, if I had to change them around, if you look at them carefully, we have an a, b squared, and a c. In this one, I still have an a b squared, and a c. This last one, I still have an a b squared, and a c. No matter how I change them around, those are all like terms, meaning they have the same ending. It doesn't matter if the coefficients are different. So even though the coefficients are 8 and 3, and the last one has no coefficient, anybody can tell me if there's no coefficient what that means? Was the number that should be there? No?
Isn't it 1?
It's 1. If you see no coefficient, it doesn't mean 0, it means it's only one of them. So let's say a good example that I would use to explain this is, in algebra, your letters really represent a quantity that you don't know. So let's imagine, for instance, that I have a box, and inside of that box is some sort of quantity that you don't know what it is. And let's say I represent that box by the letter B. So let's imagine that box has in pencils, for instance. And let's imagine now that I have 2 of those boxes. If I have 2 of those boxes, I would have B plus B, which is what I call 2B. So this is just to explain to you that a B by itself just represents 1B. Just I don't put the number 1 there, right? So anytime you see an algebraic term that does not have a coefficient, the coefficient is really 1, but we don't write it. All right, so I just explained to you what like terms are, and then we're going to look at the one that is not a like term. So this one here is not a like term, simply because all the time for the other like terms that we were looking at, we had an A, a B squared, and a C. But in this case, we have an A, we do not have a B squared, and we have a C squared. If the letters are not exactly the same, just like how we had a B squared consistently, if that changes, it's no longer a like term. A like term literally just means terms that look alike, right? So I'll give you some more examples. Clear this. So like terms, for instance, or actually you could tell me, I'm going to put 4 terms. So let's call these, I'm going to call these number 1, number 2, number 3, and number 4. Can anybody tell me which 2 of those are like terms? Okay, so somebody,
1 and 4.
everybody's in agreement?
That's right.
Yes, that's correct. Thank you. 1 and 4 is correct because they both have A, B, and Q. The other 2, would they have any more like terms, any more periods of like terms? No. Good, so we get that. Let me try one more. Okay, so let's call these now. Again, this will be A. Try that. 3. So tell me which ones will be like terms. You know, I could change around the order of the letters in any direction. Okay, so I have somebody saying 1 and 3. We in agreement with that? Yes? Okay, so
And
that's
2
correct.
and 4.
Yes, and 2 and 4. Now this one here at the bottom, even though it has this divided by 2, that doesn't make a difference. That is still that's a coefficient. As long as it's a number, so just another coefficient. As long as the letters are the same, those are the same. So good. So I think we can move on. Right, now the value of understanding what's the difference between like terms and terms that are not alike is that you can add and subtract together like terms. You cannot add or subtract terms that are not alike. So for instance, if I go back to my example where I had, so I moved it, where I was looking at boxes of pencils, and I have, let's say I have boxes of pencils, and let's say I have crates of rulers. I can only add a box of pencils to another box of pencils. I can only add a crate of rulers to another crate of rulers because the letter that I'm using contains more than likely a similar amount. So think of it like that. Think of the letter as a placeholder or a holder of some quantity, like I said, that you don't know, but the same letters have the, so one letter holds one particular quantity of something. So my box here had in pencils, they can only add pencils to pencils. My crates here had in rulers, they can only add rulers to rulers. So if I'm adding, for instance, if I have 3b plus 2b minus, let me put 5c, and put 2c minus 2b plus c. So in this particular case, I can only add the terms that are alike. I simplified it in this case. So what you would need to do is that you would need to join together the terms that are alike and then add or subtract those together. What I will tell you though is that when you move them around, take the signs with them. So for instance, this 3b here, there's no sign, that's a positive term. This 2c has a plus. The sign is always at the front of the term, at the beginning of the term. So this is a positive 2c. This is a negative 2b and a positive c. So when I group my terms together, I will have to group together 3b with my other b. So that will be a negative 2b. And then I will group together my positive 2c plus just my c. So my answer, I will work out the b's together, and then I will work out the c's together. So my answer would be 3b's minus 2b's would obviously leave me with just 1b. And remember, we just write that 1b as b. And then I get my other answer. 2c's plus one more c would give me 3c's. Now that can be applied whether it's something as simple as this or as complex as the other terms that I was using just now. So let me do a more complex. Let's go back to the lecture note. Online? Yes or not? So we have the first question. We have 2a plus 3b, this one here that I'm looking at, minus 5a minus 7a plus 8b minus 9b. Now the way that I wrote it out for you here, you're free to do that also, but I personally prefer just rearranging them and getting out your answers, but nothing's wrong with doing it like this. So what they're doing is just collecting the terms that belong to each letter. So for instance, they're finding all the a's, which is the same 2a minus 5a and minus 7a, and they put the 2, the minus 5, and the 7 here, and just put the a at the end. And then they did the same thing with the b's. So the b's, we have positive 3b, positive 8b, minus 9b. So they put the positive 3, positive 8, and the negative 9 all together and put b. Whichever one you prefer is entirely your choice. They both will give you the same answers. Right? So you'll just work those out, and then you will get the same answer. So if I had to do it the way I prefer, let me move all this off of here. So 2a plus 3b. And then we have minus 5a minus 7a. And then plus 8b minus 9b. All right, so I will try it the way that I said. Put just all my common letters together. So I'll put all the a's together. So that will give me, these are my a's here. Remember to take the signs with them. And I will have 2a, sorry, not plus. It'll be minus because it's minus 5a next. Then it'll be minus 7a. Then it'll be plus 3b, plus 8b, and minus 9b. And then it will just work that out. In terms of working it out, we go back to what we did at the start of the class. And you can do these in groups. If I were you, I would start by working out this section here first. And we remember that whenever we have to subtract, and we're subtracting with the same two negative numbers in this case, all you basically have to do is add them together and put back your sign. So the answer for this section here will be negative 12 But as I said, you don't necessarily need to do all that. When you get to this point, use your calculator. Put this part here in your calculator and get your answer. So you will put in 2 minus 5 minus 7. Somebody work that out quickly and tell me what that part is. And then just put back your A. 2 minus 5 minus 7. Anybody?
Minus 10A.
Minus 10A. Good. And then you'll do the next section, which is 3 plus 8 minus 9. So you can do that part.
Equals 2.
2B.
Good. Positive 2B. Now you don't write the sign here in the middle until you actually figure out what the number is. So let's say, for instance, instead of that just being 2B, let's imagine that it was negative 2B. Then obviously your answer here in the middle would have changed to a minus. Okay? And if you look back at your notes, you'll see the same answer we have here. So you choose whichever method works for you. They're both available for you to use. All right, so we have another one. I just want to chat though, because the reason, and there are some people who might think that I might be going through things that are obvious, but I understand that there's some of you who would have failed math a lot of times who think that you can't get math done or something. Everybody can get math done, and I'm going to try to move at a pace that I think everybody can move at. So instead of the people who are looking at me like, what on earth am I talking about? Just raise your hand. Tell me if you need me to go over it, and I will. And I'm also going to be doing some of your tutorials. Somebody else is going to be doing one. There's another person doing your lecture, so you have a second opportunity to ask. Your practical, sorry. Right. So we have negative 2A plus 3A squared. Let's do that on Jamboard. You should try doing it along with me and see if you get the same answers, just to make sure you understand it. So we have plus 3A squared minus 6A squared, and then plus 5A. So again, collect the terms that are alike or that have the same ending. Remember to put your equal sign. In algebra, we normally put it at the beginning of the sum instead of at the end. So this is what you should be getting. Okay, and then you will work out this one. Remember, when we have two different signs, a negative and a positive, put the sign in the bigger number and subtract. Bigger number is a positive number, so you'll get a positive. When you subtract 5 and 2, you'll get 3. And then for this side, put the sign in the bigger number, which is negative. Subtract the 2, and you'll also get 3. Did you also get that? All right. Let me give you one to do. I'm going to be doing that this class, but I can't continue to stop and give you time to practice simply because we're already a week behind. I only have 2 hours of lecture. Most of the courses have 3. So I have to move pretty quickly. But like I said, you will have the opportunity to practice when you go into your practical. You're actually going to have to practice in class live. So your first practical will be next week, Fridays that y'all have to, I think. I remember the date. But
Thursday, ma'am.
thank you. So when you come, you will have to come, those who are coming here, you need to come with some sort of device, whether it's your phone, laptop, tablet, anything, and you're going to be asked to do questions online digitally at the beginning of the class, like the first 20 minutes or so, and then the tutor will spend some time either
Actually, shut your door saying, big man. I can't hear.
Pardon? Right, so then in the second half of the class will be spent either going through some more of the questions that we did in class or going through those questions if you have difficulty. So point is, just make sure that you're following. So let's try this one. Sorry, I'll continue on me. Try that one. This was an X here. Didn't write it properly, but it was an X. Anybody was able to get the answers yet? Can I have one person come and show me what they have before I go through it? Anybody? Should be X. Okay, this part is this part is this is work. This part here is fine, but not this one. All right, so I'll go through it. All right, so what you should have, you have the first part right. You should collect together your BX's first, or AX's, it doesn't matter. And we should have 7 BX minus 10 BX. And then you should also have your AX's. So you should have plus 4 AX. Remember, as I said, carry your signs with you. So then we're going to do this one next. This will be minus 3 AX. And then we have that additional term that I don't have space for, which is 5a squared x. Now, if you notice, that term of the 5 is not similar to any other term because it has a squared and the other terms are just a. Right? So that one, you will leave that on its own. When you're finished, you'll just add it back on because you can only add together like terms. So your first part you will get 7 minus 10. You can just turn that around and call it, well, do the same thing that we said we were going to do, which is put the slightly bigger number, that's a negative, subtract them, you're going to get 3. So that's 3bx. And then we're going to deal with over here now. and that's just 4 minus 3, which just leaves us with 1ax. So that's going to be plus 1ax, which is just ax. And then you're just going to put back this term here, plus 5a squared x. All right, so let's move on. Unless anybody has any questions. Oh, you need to see it. What's strange is that when I have taught online before, it's the online people who don't answer, not the people in front of me. It's very interesting. Is there anyone who absolutely does not understand anything I've done for you morning? Be honest. I'm not gonna laugh right now. Yeah, just I didn't have any more space. Okay. All right, we can move on. Yeah. Okay, so we have the next one is fractions. Um, just remember to, in the event that this does look complicated, because I know there are people who don't understand, but they're not going to say. Just remember that you have full option to use your calculator. And when you're using your calculator, for instance, in this case, you would have just put 7 minus 10, get your answer and put it here. And then you would have had your 4 minus 3, put your answer here. Just if the answer comes out to be a negative, you would put your negative answer. So let's say, for instance, instead it was 3 and minus 4. Here you would have had, gotten a negative result, so you would put back minus ax. And, right, still leave the last one. So if the negatives, I know that there's some people who struggle with remembering the difference between positive and negative numbers in terms of these little rules that I said. So if that's a problem for you, use your calculator. All right, so fractions. Now, I know that people struggle with these from primary school straight up, but you have a calculator, and most of you should have a calculator that can do fractions. If you don't, you need to get one. You should have a button on your calculator that should look like this. Get that? Save yourself the stress of having to work through fractions, but I'm still going to go through them because I'm supposed to. When you do use this button, let's say you have to put in 3 over 4 on your calculator, all you will do is put in 3, press the button, it will come up looking like that, and then put 4. Some calculators might not have it written like this. People in the back can't hear. I'm not quite sure what I could do about that, besides to tell them to come up to the chairs a little bit closer. There are a lot of chairs here in this middle section. There's some at the front. But I will try to speak a little bit louder. Right, as I was saying, when you use this button, it gives you this symbol here that just means over. So 3 over 4 is just written like that. Some calculators, I was going to say, might have a button that looks like that. Depending on the brand, I think Casio calculators are usually like that. If you want to put in a mixed fraction, so let's say you want to put in 1 and 2 over 3. If you have this button here, you will just press it between each number. So you would just have 1, or it will come like that, 1 over 2 over 3. And you could go ahead, add, subtract, multiply, divide, do whatever it is that you need to do without having to hurt your head about that. I would advise all of you now to get a calculator if you do not have one, a regular scientific calculator, but look for the one with the fraction button on it because not all of them have it, right? If you do choose to go on by one. All right, so note that when the denominators of fractions are the same, we add or subtract the numerators as indicated by the sign. So fractions with the denominator, which are the same at the bottom, are simple. All you need to do is to add together the numbers at the top or subtract the numbers at the top. So we have here 3 over 8 plus 1 over 8, just is 3 plus 1, again over 8, which is 4 over 8. That's simple stuff. Same thing with subtracting. We're going to go through this second one. So we have 3 minus 7 plus 9 minus 5. And these are all over 16. Once they have the same base number, you just add or subtract them like you do regular numbers. So basically what you can do is you can just put all of these over 16 and just work out the top just like how we did the ones at the beginning. So I will put my negative numbers together and my positive numbers together, and you'll have 3 plus 9, right? Those are both positive. And then you have both your negative numbers. And remember, once you have two negative numbers, you are going to add them together. Your answer for the first part will come out to be 12, and the second part will come out to be 12 over 16. So obviously 12 minus 12 gives me 0 over 16. And 0 over 16 is the same thing as just 0. Go over it one more time. Up to which point? There? You mean how I did that? Right, so I just started because they all have the same base denominator. I can put all of them over 16 once they're the same number. So then I just did what we did at the beginning of the class, where I collected, well, not collect like terms, it's not algebra, but I put the positive numbers together and the negative numbers together. And I know that once I have a negative number subtracting another negative number, I know I add them together and just put back the negative sign. So I started with the positive ones. So I had a positive 3 and a 9. And then I had a negative 7 and a negative 5. So remember, we just put that negative on the outside, but we can add together that 7 and 5 because they're both negative numbers, right? So my answer there, I got 12 here. And I have to put my minus subtraction, and I have 12 here. And 12 minus 12 is 0. And I just mentioned that 0 divided by any number is still 0. Okay? So that fraction sign means the same thing as just being divided by something else, which is something that you should know, but I'm just going to repeat this in case. What I will try to do for the next lecture is I'll try to post well, we're going to continue with this lecture note, but I'll try to post it in future a little earlier, but you only had access to e-learning from today, which is why it was posted today. It would be in your best interest if you can print it and bring it along with you for class. Pardon? Well, this document is pretty long, so this will go into next week, right? But I will post, whenever I move on, I will post it beforehand. All right, moving along smartly. When the denominators are not the same, we must find a common denominator so that we can proceed in the examples above. This is done by finding a number that all the denominators can divide without a remainder. So when such a number is identified, we multiplied the name, right, let me go back, not move too fast. So this is just basic LCM that we're going to end up doing. Let me talk about equivalent fractions. Let me go ahead. When such a number is identified, we multiply the numerator and the denominator of each fraction by the corresponding factor, which leads to the identified common factor. Fractions formed in this way are called equivalent fractions. So we have some examples of equivalent fractions. We have 3 over 4. If I multiply the top and the bottom by 2, we get 6 over 8. 6 over 8 is equivalent to 3 over 4 because all I need to do is divide that 6 over 8 by 2 and I'll get back 3 over 4. Other examples, if I have, so let me show you what this looks like if you're actually doing it in a question. Suppose you had 7 over 10 plus, let's say 1 over 5. You have two different denominators. You will try to turn the second one into a fraction that has the same denominator as the first. You can't go the other way around. You can't do anything with 7 over 10 because there's nothing that can divide 7 besides itself. So what you will do is that you will make 1 over 5 the equivalent fraction that will have a denominator of 10. So that 1 over 5, all you need to do is to change the denominator to 10, you'll multiply that by 2. But whatever you do to the bottom, you must do it to the top. So you'll multiply the top by 2 also, and you'll end up getting 2 over 10. What that allows you to do now is to change this sum to become 7 over 10 plus 2 over 10. And then once you have the same base, you can just go ahead and add together the top, 9 over 10. Right? Sure, you can go over it. So I just explained, let me go back a little bit. If I had a question, for instance, that was 1 over 10, let me not use blue. Some people may not be able to see. If I had, let's say 3 over 10 plus 5 over 10. As long as my denominator, which is these bottom numbers here, as long as those are the same thing, I can just add the top numbers together and put back the bottom number, the denominator. So my base will remain 10, and I'll just add the 3 and the 5 and get 8. Done. If I have fractions that do not have the same base, like the one that I was trained to do, I need to turn one of the fractions in such a way, one or both, so that they have the same denominator. So I can look here and see, I can't do anything with this one, but I can do something with this 5. I can turn this 5 into a 10. Just find a number that you can multiply it by, that you can turn it into the same denominator of the preceding one, or vice versa. So I know I can multiply this 5 here by 2 to get 10. But if I multiply the 5 by 2, I must also multiply the 1. I can't do the bottom without doing the top. So then this one up here, I have to multiply that by 2 also, and that will turn this fraction into 2 over 10. Now I can add that on to the other fraction because they both have the same denominator, and I will just get 9 over 10. So what I did here on this part, this is what we call an equivalent fraction, and the fraction that will be equivalent to it will be 2 over 10. Those are equivalent fractions. Fractions that you can multiply entirely by another number, you get another fraction. Those two are equivalent fractions. So let me give you another example. Yes, people are writing this, so I'll give you a minute. Now there's a case where you could have two fractions that might not be so easy. So let's say I have 3 over 4 minus, let's say 1 over 5. Now I can't turn 4 into 5, nor can I turn 5 into 4. But what I can do is to multiply both of them by a number so that they become the same. Right? Anybody can tell me what that number would be? Or what number would I want to get? 2? 20. Correct. So both the 4 and the 5 timetable, the lowest number that both of them can go into would be 20, which is the same thing as your lowest common multiple. So what I would do, an easy way to do it, is actually just to cross multiply. So what I would do is I would multiply 4 by 5 and multiply 5 by 4, and at the same time multiply 4 by 5. When I do that, remember whatever I do to the bottom, I have to do it to the top. So if I'm multiplying this 5 by 4, I also have to multiply top by 4. If I'm multiplying the bottom here, the 4 by 5, I also have to multiply top by 5. And that will end up giving me 15 over 20 minus 4 over 20. Your goal is to just get the bottom to be the same. My answer here would be 11 over 20. Same thing. Yeah, that's fine. And there are many ways to do these. As long as you get the same answer, it doesn't matter which method you choose to use. What if you had, let me try a different one. What if you had 2 over 4 plus 5 over 6? Can anybody tell me what we would do with those denominators to get them to be the same? 12, correct? So I'm going to do it like how this lady just showed me she did it on her butt. Your lowest common multiple, in this case, would be 12. Think about your 4 timetable, your 6 timetable. The first one you get that's going to be common is going to be 12. If you had to cross multiply like how I did, you would get 24 and you would just have to reduce when you're finished, right? If you choose to multiply the 4 by the 6 and the 6 by the 4, but good practice is to use your LCM. So what we have to do at this point is to look to see how many times you have to multiply, what do we have to multiply 4 by to get this 12? You have to multiply that by 3. Whatever you do at the bottom, you do it at the top. Look and see what you have to multiply 6 by to get the 12. Multiply it by 2, do the same thing at the top. Your answer will be 6 at the top here, plus 10. Your answer is 16 over 12. And you know, you can't leave that like that. So you will need to turn it into a mixed fraction. Check and see how many times you can get 12 out of 16. Obviously only 1. And you will be left with 4. So you will get 1 and 4 over 12. And we can reduce that. So to reduce that, all we need to do is to find a number. Am I going too fast? I figured there's things that we know already, right? So just a recap. So all you need to do is to cancel that 4 over 12 and to know if you have to cancel. If you have a fraction that you can see that the top, the numerator and the denominator can be divided by another number, you need to cancel it or bring it down. That's what people say. So you have 4 and 12 can both be divided by 3. So you will get, just go out here. We have 1 and 4 over 12. And I can divide, sorry, they can both be divided by 4, not 3. So I will have 4 into 4 here is 1. And 4 into 12 here is 3. My answer will be 1 and 1/3. I apologize if it looks confusing. Ideally, we would have needed a board, but because the people online also have to see. I don't really have a choice but to do it on the tablet. If I could go over it again. If you can use it again, no. No. There's no more reducing after this. This is it. This is your last answer. No. Right, so this is simple stuff. I'm going over it for a reason because you will do this same thing with letters. You'll do it with algebra. And the same rules apply. So let's look at some examples like that. So we have here for part 2, no, this is going back to the equivalent fractions. I went a little further ahead. But we have a over 3, and if we wanted to turn that into an equivalent fraction, they're just choosing random numbers here to show you what an equivalent fraction looks like here. And they just chose to multiply it by 7, top and bottom, just to show you that 7a over 21 is equivalent to a over 3. I could have multiplied that by any number, 5, 4, whatever I chose, so just an example. Ooh. What happened here? All right. So then we have another example of an equivalent fraction here, where you can multiply it by another letter instead of multiplying it by another number. So if you notice in these cases that we have done so far, we always multiply it by the same number top and bottom. You can do the same thing in algebra by multiplying both the top and the bottom by another letter. So we have y over p, and we're multiplying it by q. We have y over p, and we're changing that into an equivalent fraction by multiplying it by q. So we'll get y multiplied by q over p multiplied by q. And that gives me, we should know that when we're doing algebra, we don't write multiplication signs, they disappear. So that gives us yq over pq. And this fraction is the same, sorry, not the same, is equivalent. Those two fractions are equivalent just because they're multiplied by a common term. Good with that? I could give you another example. Suppose we have a over b. And let's say I wanted to multiply this by a. I will multiply the top and the bottom the same way. I can have a by a multiplied by b by a. The bottom is pretty simple. Just remember to keep your letters in order, in alphabetical order. So the bottom I will put as AB. Anybody can tell me what the top would be? A squared. Right? So same rules apply, whether it's regular fractions or algebra. However, you can't use your calculator to do algebraic fractions. Well, not these kind. If they have numbers, you might be able to do some parts, but you still need to understand the method of how to do the fractions to be able to get algebraic fractions done. All right, let's move along. So, I went through this already, but I can go through it on here. Find the common denominator, write the fractions as equivalent fractions, and simplify. That's the rule. So, I did a question similar to this just now. I don't think I need to go over that again. So I think I'll move on. But I guess you could look at the method that is written out in here. Similar thing to what I did, but I did it all at one time. You have your 4 and your 6. You know our common denominator is 12, but they chose to expand it out. To me, this takes a lot more time. The way that I did it before is a little bit easier. But you are free to look at that when you have time. So I'm going to do the next example out for you. A half minus a third. And then we have plus a quarter minus 3/8. So what you would need to do is to find a number that all four of these numbers can divide, or we would say go into. Anybody tell me what that number is? 24, that's correct. So I'll put 24 as my base. And then what you would do is to just figure out how you're going to turn these denominators into the number 24. What are you going to multiply each of them by? Anybody has any problems figuring out how we got the number 24? Or is everybody good with that? There's no shame in here. Everybody here in the same boat. So if you're not sure, you need to say. Okay? Right, so now I need to turn each of these numbers into 24. So to get from 2 to 24, I need to multiply that by 12. And remember, whatever you do at the bottom, do at the top. To get from 3 to 24, I need to multiply that by 8. Do the same thing at the top. To get from 4 to 24, multiply that by 6. Same at the top. To get from 8 to 24, multiply that by 3. Same at the top. So now you just have to work out the top parts because you know the bottom answers are already all 24. You'll have 12. 1 12 is 12. 1 8 is 8. Put back your signs in the middle. 1 6 is 6. Put back your subtraction sign, and 3 3s are 9. So we're doing the same thing that we've been doing from the start of this lecture, where we will put the negative terms together and the positive terms together. So we're going to start with our 12, and then add on the 6 because those are both positive. And then I will take away from that my negative numbers, but remember, since they're both negative, I can add them. So I will have 8, and I will add that to 9. So I gotta write a little small so it can fit. Do I even think it can? All right, let me see if I can write that a little better. Hold on. We had our positive 12 plus 6, and then minus 8 plus 9. I apologize. Can't do any better than that. So put that back over 24. So 12 plus 6 will give me 18. And then we have our minus 8 plus 9, that is 17, all over 24. Our answer will come out to be, I'm going to put it out here, 1 over 24. Just give you a minute to write. All right, I just want to check the chat online because I'm still seeing a lot of messages. Okay, so Annalisa, yes, you're finding the common multiple. And yes, you're finding the common multiple. As I would have said before, I can't see your responses if I'm sharing my screen. So just interrupt if you have questions. All right, moving on. Okay, so moving on away from fractions. We have some rules for, actually, Actually, Wanda, let me show you something before I move on to there. Let me show you how it will incorporate. Um, it's not going to be on your notes, but let me show you how you would incorporate algebraic fractions. Anybody could tell me how you think you would choose to work this question out. Let's say put 2a over 9. Anybody thinks they could get that done on your own? You don't have to come up or anything, but do you think you could do that? Same rules that we did just now. Doesn't change. Just try it on your own and see if you can get it done. Don't let the letters scare you. Same principle. All right, so I'm going to go ahead and try it now. So you could already see you have one number that can become an equivalent fraction so that you will get both denominators.
5a over 9.
So somebody said 5a over 9. I can work it out now and tell you. So just put that up in any corner. Thank you to that person online. So right, we can see that we can turn this 3 into 9 using equivalent fractions. Just multiplying that by 3, multiplying top by 3. So we will get our denominators to be 9, and it will become 3a plus, we put back our 2a, we haven't done anything with that fraction, and that person is correct, 5a over 9. So you see, regardless of whether it has letters included, whether it's algebra or not, the same rules apply. I'm going to let you try one more before I move on. Anybody need to write that? All right, so try this one for me. Let me hear you again. Sorry, I forgot to say it from before, right? But you can take all your masks. You don't have to keep them off for the entire time once you're already apart. I forgot to say that at the beginning. So 1 and 1C over 12. I don't think so. Wait, what happens to B?
3b plus c over 12.
Somebody said, repeat that again for me. 3B plus what? Okay. All right, let's work through it.
c
Okay, so you have the 12 part correct. The person who is online. 12 is right. But I think you forgot to multiply your numerator.
I have 9b plus 4c over 12.
Yes, that's correct. Right. So we figure out everybody seems to figure out what your denominator should be. So that's good. But just remember that you have to turn these bottom numbers, these denominators, into this one. And to do that, you have to multiply it by a number. And when you multiply the bottom, you must also multiply the top. Don't forget that part, right? So to get from 4 to 12, I must multiply by 3, correct? When I multiply by 3 here, I must also multiply by 3 at the top. So that 3b will turn into what? 9b. Put back my plus sign. Now I have to turn this 3 here to be this denominator, which is 12. To get from 3 to 12, I must multiply by 4. That means I must also multiply the top by 4. C multiplied by 4, just 4c. Now, I think what you might have done is probably try to combine them. Remember, we can't combine a B and a C. We can only combine B's with B's or C's with C's. We can't add those together. Is there anybody who is having problems? I will ask one more thing. Are we good with this, or do I need to do another example? Okay. I will still do one more because my heart and soul is telling me that people still don't understand. Let's make it a little bit more complex this time. Let us try more than one set of fractions. So try this one for me as well. Do not use red. Hold on. Try that one for me. Now, just as a hint, make sure that you put your like terms together first before you start to work it out. And make sure you carry the signs with you. Just gonna start online quickly.
Mom,
Go ahead.
Um, when we do the like terms, after we find out, because my first one when I did the like terms with the AA, I get 6A over 9, and then the other one I get 10 over 5. Do I have to do something further with that?
I want to, so what you would need to do is you can see if you can put together the denominators, but if they are already separated, the like you do not need to do anything. So I'll go ahead and show you.
Okay.
I'm Miss Ford. Hello. Is the answer 10A minus 36B over 45?
Yes, that's correct.
Yeah.
Right. So to the first person that was speaking, that's what I meant. You might have to, same thing that we were doing in terms of your denominators, turning them into the same LCM. That's the only thing that's required after that part, right? So let's work through it and see. You will start by putting your A's together. I assume that everybody would have done that. So you would have gotten, well, the first thing actually that you could do, you have two options. You could have either worked out your LCM first for all four numbers, or you could have just put your like terms together. Doesn't make a difference. So I could put my 8A over 9 minus my 2A over 3 plus 3B over 5 minus 7B over 5. So the person who spoke to me first, I think you said 6A, that part would not be correct. But your 10B would be right if it is that you are working these out as two separate fractions. The easier thing to me would be to work them all as one, just as how we did in the other example. So I would recommend that you find the LCM of all four, well, not four numbers, because you have 5 twice, so these 3 numbers. And the easier way to do it would just be to find the LCM of 9 and 5, because I know whatever 9 can go into, 3 can also go into, so I don't need to include 3 in there. So the LCM of 9 and 5 would be 45, as the second person said. And then all I would need to do is to multiply each of my denominators by whatever I need to multiply it by to get that 45. So for me to get 9 to turn into 45, I'll multiply that by 5, do the same thing with the top. So that would give me 8 5s are 48. And then I'll do the 3. And to get from 3 to 45, I'll need to multiply that by 15. If you don't want to work that out in your head, all you would do is take your 45 and divide it by 3 to see what number you need to multiply by. So when I multiply that by 15, 2, I have to put back the subtraction sign from here first. And 2 by 15 gives me 30, so that will be 38. And then the second part now, to get from 5 to 45, I know I need to multiply that by 9, and I also need to multiply this one by 9. So I do the same thing with the top. I'll put back the sign here, this plus, and I'll get 9 3s are 27, B, and then 7, sorry, I said 3, sorry, yeah, 9 3s. Then I have to multiply 7 by the same 9 as the denominator, and I know that 7 9s are 63. Again, all of these parts of these calculations can be done in your calculator. You don't necessarily need to do them in your head. So let me bring that around a little bit. And then you will just work out your like terms. So you can clearly see, I'm just gonna write my answer under here. 10A minus 30A will give you 10A, and I think that person, the second person said that. And then you have 27B minus 63B. Somebody can put that in the calculator quickly. We don't need to do that in our heads. Put in the calculator quickly and tell me what the answer is. Just put in 27.
Negative 36B. Over 45.
And you put that back over 45. So that's your answer. Do we have any questions? Who's, go over again? Sure. All right, so let me just clear, I'll erase it back over. Just clear this section. So I started first by putting my like terms together, put the A's together and the B's together. So I did the 8A over 9, and I added that on, sorry, not add. I was about to say add, but if you look at the next A, it has a subtraction sign. So I have to take away the 2A over 3. Then I do my B's, so I'm going to put my positive 3B over 5, and then I'm going to take away from that minus 7B over 5. And now it's just time to find our LCM. And what I said, you only have to find the LCM of technically 3 numbers because you have 5 twice. So it's 9, 3, and 5 you have to find the LCM of. But if you notice, you know that 9, 3 can go into 9 already. So whatever number you use for the LCM for 9 and for 5 will also be the same for 3. So you don't need to include 3. So you just have to think of what number can both 9 and 5 go into, the smallest number that is, and that number was 45. And I put it at the bottom. And then all I needed to do was to turn every single denominator into the number 45 by trying to figure out what number can I multiply each of those denominators by to get that 45. So all I would need to do here, to get from 9 to 45, multiply by 5. Do the same thing at the top. So now we have 8A by 5, that just gives us 40A. Then we go on to the next one. To get from 3 to 45, I was saying if you don't know in your head what that answer is, just take 45, divide it by 3, you'll figure out that is 15. Multiply the top by the same thing. So then I will put back the minus sign here, and I'll multiply the 2 by 15 and get 30A. Move on now, put back the next sign here. I'm doing 5 now. To get from 5 to 45, I must multiply by 9. Do the same thing with the top. And 3 9s are 27, that'll be 27B. And then the last one, multiply again by 9. Multiply the top by 9, and I would have gotten, put back the minus sign here, and get 63B. So our final answer, I'm just going to put it at the top. Our final answer, we just work out the A's and work out the B's. So we had 10A from the 40 minus the 30. And then the 27B minus the 63B, our answer was negative 36. So you see this plus that's here, we wouldn't put this back, we would have to put a minus now because it's a minus 36. B. And then we put that all that over 45. And that's our answer. We can't do anything further because these are not like terms. You can't add or subtract a and a b. Only A's to A's or B's to B's. We good with that now? All right. I'll give you, anybody else needs to write it off?
So, quick question, Ms. Ford. So can I have worked it out as 2 separate ones and still get the same answer?
Yeah, so I'll show you that now. But you will still have to join them together at the end. So let me show you that. Hold on, let me make sure I can remember what the sum was. Oh. Hold a second for me. So we have 8A over 9. Plus 10 minus 2A over 3 plus 3B over 5. And then I think it was like minus 7B. Okay, so if you were to work this out as 2 separate ones, you would have done this side over here would have been easy. You would just put back that 5 and then just subtract those two terms because they're both similar terms. The reason why I could just put by the 5 here is because they have the same denominator. So I would end up getting here minus 4 because remember, once we have a positive and a negative, we take away and put by the sign in the bigger number. So that would have been negative 4b. And then over on this side here, all you would have needed to do was be to turn this 3 into a 9 so it can match the 9 that's here. So you would multiply this by 3 and multiply this by 3, and you would get 8. Well, I can work it out in 2 steps. I'll do it in 2 steps here. You would get 8a minus 6a. Both of those would have been over 9. And then when I work that out further, I would have gotten 2a over 9 minus 4b over 5. I just put this back. So what you would have to do now is that you would have to use your same LCM to get out your answer. And you would need the base, again, because it's 9 and 5, just like what we did before, to be 45. Multiply your 9 by 5 to get 45. Do the same thing at the top. We get back our same 10a. And then we can multiply the 5 by 9. Do the same thing at the top. And then we will get out our same 36b. So you get the same answer. If that second option is easier for you, feel free. The method doesn't really matter as long as it makes sense. Something else I would like to recommend to you, because I see some people who look a little bit defeated already. As long as you try, you will get marks in this course. As long as what you are doing, whether the answer is right or wrong, as long as it looks like you are doing something that made sense, you will get marks. In math, we don't mark the final answer, we mark all of your steps. So don't be intimidated by whether or not, if you have a completely wrong answer, but you can see logic in what you're doing, you will get marks for it. I hope that answers your question, the person that asked you that online. We can move on.
Yes, thank you, it did.
Pardon me?
Yes, thank you, it did.
Okay. All right, let's move on. So we have multiplication and division of real numbers. So we have some rules. A positive number multiplied by a positive number gives a positive result at the same sign. So if you have, for instance, 3 multiplied by 4, those don't have any signs on them. When I'm talking about signs, they don't mean multiplication. They mean positive or negative signs. If those numbers, like 3 and 4, don't have a sign on them, they're both positive. So your answer would just be 12. So as long as they have the same signs, they are positive. This same rule applies if you have 2 negative numbers. 2 positive numbers or 2 negative numbers will always give you a positive result. So if I had negative 3 and I multiply that by a negative 4, I will still get a positive 12. So as long as the signs are the same, your answer is a positive. The only time when your answer comes out to be a negative in terms of multiplication is if you have 2 different signs. If one is negative and one is positive, your answer will always come out to be a negative. So some examples of that are, if I had 3 multiplied by negative 4, I'll get negative 12. Or if I had negative 3 multiplied by 4, I'll still get negative 12. All right, so we have some examples here already, so I'm going to rub out these ones that I just did. Right, so we have here a positive 3 and a positive 5. Even though this is written like this here, you would not normally see a question written like that. It would just be written as the regular 3 because that already means positive 3 multiplied by 5. This is an error. I apologize for that. Should be 15. And then we have negative 3 by negative 6. Again, same signs. As long as the signs are the same, your answer comes out to be positive. We have an example here where our signs are different. Again, this question wouldn't normally be written like that. I just did it so that you can see what are the positive numbers, but you would get negative 4 multiplied by 7 That gives you a negative 28 just because one of the signs is negative. If any one sign is negative, the answer has to be negative. Then you have a case where you have this one here. This is division. The same rules for multiplication also apply to division. It doesn't change. So we have here 20 divided by negative 5. Only one of the numbers has a negative sign. They're different, which means the answer comes out to be negative. I'm focusing on what the sign here is as opposed to what the answers are, the numerical answers are. Then we have here two numbers dividing. Both of them are negative. My answer comes out to be positive. Okay, so just to test and see, what I would normally do is give a little grid, and I would just show that two positives, let me write that a little better. A positive multiplied by a positive gives you a positive, and then you would have, oh goodness, what is this happening? All right, let me write down Jamboard instead. So a positive multiplied by a positive gives you another positive. Negative multiplied by a negative still gives you a positive. But any combination of the two will give you a negative, right? So if you want something to write down, you can write that. Now, if you have pairs of numbers that are the same, so if I give you a long set of numbers and they were alternating positive and negative, and you had to figure out what your total answer would be, you can group together terms that are the same. So let me explain to you what I mean by that. Let's say, for instance, you had negative 3 multiplied by 2 multiplied by negative 4 multiplied by 3. So you have many different positive and negative numbers here. What you can do is use the same rules, and you know that the same signs will give you a positive result. So you will just group together the negative signs and the positive signs. So I will just put the 2, multiply it by the positive 3, and multiply the negative 3 by the negative 4. Okay? So this, I just put the positive numbers together, and then I put the negative numbers together to get this section over here. And I can easily see the beginning part will give me 6. Multiply by those two negatives with the 3 and the 4 will give me a positive 12. My answer will be 36. I'm not going to spend a lot of time working out the answers, but I just want you to tell me for the next question I'm going to put down. Just tell me what you think the sign would be. What if I give you what would the sign be, positive or negative? Anybody can help? Positive, that's correct. And you can know that it's positive because I have a negative here and I have another one here. You can think of them kind of like canceling out each other. If you have two negatives, think of it as canceling themselves and becoming a positive. So once you see two negatives, you can cancel them and create a positive. What if I give you this one instead? Will that answer be positive or negative? Negative. There's no other negative to cancel that one out with, so it will have to remain negative. Your entire answer will have a negative sign. What about this one? Negative, positive. Positive or negative? How many people say positive? How many people say negative? Right, so negative is correct. Here's the reason why. These two will cancel, give you a positive, right? So you end up here with a positive 6. But then you have a negative left over. That doesn't have anything to cancel with. So think of them like pairing them. If you have 3 terms that are negative, you're only able to pair 2 of them, which means you will have a negative left over. Your entire answer will be negative. I hope that's clear. We can move on. I very much apologize bringing you down to the end, all down to 6 o'clock on the first lecture. But like I said, we're already a week behind. And UE doesn't really let you drop topics or say you don't finish, so I don't have a choice. So moving along. Oh, so this was just saying the same thing that I was saying here at the top. Basically, that the positive sign can be left off the positive number. We don't normally write it. However, the minus sign must always be written. You can never leave that off. A number without a sign is assumed to be positive all the time. Now, when letters are multiplied together, we bring them together, and we do not include the multiplication sign. I mentioned that briefly earlier. So we have here, let me make this a little bigger. All right, so we have here A multiplied by B. Just remove that multiplication sign, and it's AB. So if you see, for instance, a term like XY, you have to know that that means X multiplied by Y, because once you see letters joined together or a number and a letter joined together, that means that it is multiplying. You have to know, you have to remember that in algebra, we do not write multiplication signs at all. So as long as they're stuck together, they are multiplying, right? So you don't have to guess about that. So XY means the same thing as X multiplied by Y. For instance, 7A means the same thing as 7 multiplied by A. Okay? Any other sign that we use, we always write. If it's 7A, it was supposed to be a 7 plus A, we would write the plus sign. We will write the minus sign. If it was division, we will write it like this, 7 over A. We don't usually write division signs either. We write division signs like this, the dividend. That's how you write a fraction. That's how we normally do it in algebra. Seven over A means 7 divided by A. Right. The only one that means multiplication is if they're just stuck together. From the time you see this line, that means division. If you just see it like that, right. Fractions are basically just numbers dividing each other. That's really what they are. I can't hear you. Yeah, it's the same thing. Yeah, it's the same thing. Right, and just to show you that it's the same thing with regular fractions. If, for instance, you have a fraction that is, let me use an improper fraction, like, for instance, 8 over 2. Now, that's a fraction, but that's still division, because I can divide 8 by 2, and I will get 4, right? The reason why fractions are written the way they are is, let's say I have 1 over 4. I can't divide 1 by 4, so I leave it like that. Got it? Yeah. But that line, regardless of whether it's a fraction or not, the line means, it's called a dividend, and it just means to divide. All right, so we have, let's start this one already. We have, same thing I was explaining here, 7 by t equals to 7t. This one that we have here, again, nothing complicated. You have c squared multiplied by b multiplied by d. Just stick them together, and that is it. If a letter is multiplied by itself a number of times, we rewrite the letter and write the number of times multiplied as a power of the letter. So what you can do, we have an example there with n. So if you have 4 n's multiplying each other, anything, actually, before I get to n, let me do a simpler one. We did this already earlier today. Anytime you're multiplying something by itself, whether it's a letter or a number, it doesn't matter what it is, you can change it to be a power. And what you would do is, how much ever number of times the letter appears, the same letter appears, you would write that as your power. So here, we said this will be a squared, and that 2 at the top represents that there are 2 a's multiplying each other. Here, for this one, we have 4 m's. So my answer here would be m, and my power would be 4 to represent 4 m's multiplying each other. If I had, for instance, b by b by b, my answer would be b, and the power would be 3 because there are 3 b's. This can also be extended by combining different groups. So let's say, for instance, I had, let me go to a different slide. Let me clear this one. What if I had a Anybody can tell me what the answer for that would be, just by looking at it? You know, we can have an A, and we can have a B, but what are my powers?
Ma'am, a to the power 3 and b to the power 2.
Good. All right, now you make it a little bit more difficult. What if we have Could anybody tell me what the answer for that would be? AB squared C. Almost there, not quite. Close. A squared, good, because we have an A here and an A here. 2 A's multiplying each other, and 2 B's multiplying each other. So we can also extend that by changing this first equation. Let me show you how. If you understand what they mean, then if you have, let's say, A squared B, and I was multiplying that by, let's say, a B squared C. No, let me change that to something else. Let me put B cubed C. What you can do is, if you know that A squared means 2 A's multiplying, and you have 2 A's here, and you have another A here multiplying, you can add those together. So in indices, these are called indices. Numbers, letters, or numbers with powers are called indices. If you are multiplying them together and they have the same base or the same letter, like A, you can just add together the powers, and that will give you the total amount that you need. You know you have 2 A's here, you have 1 A here. Your total answer will be A cubed. In terms of the B's, you have 1 B here, you have 3 B's here. Your total answer then will be B to the 4. And the C doesn't have anything else to multiply by, so we write it back. Okay, so try this one for me. Okay, so your answer should be x to the power what? 3, and y to the power 2, or squared. Good, easy stuff. All right, let's go back. So that was the top part. That was the example by number 2. Let's look at number 3 from here. This is something that I was explaining. I did it beforehand, but instead of writing division like that, like 28 divided by 4, we can write it as 28 over 4. I just explained that that line in the middle just means the same thing as division. So canceling and dividing is really the same thing, right? So whether I choose to do, let's say 10 divided by 2, or I put 10 over 2, we call the second one canceling, we call the first one dividing, they're both doing the same thing, right? So your answer for both will be 5. Just understand it can be written like that. Now, in a similar manner, when we are doing same indices, let me rub this out from here. Now that we understand that division can be written in this way as a fraction, if you have ABC here over AB. So we have ABC over AB. Anytime there is a letter at the top and there's one at the bottom, you can cancel them out together, okay? They can cancel each other out. So this B at the top here can cancel with this B at the bottom. This A at the top here can cancel with this A at the bottom. My answer would just be C. Now, what you're doing when you're canceling is that you're really dividing. But when you divide B by B, what answer do you think you would get? Anybody can tell me? Not 0. All right, let's think of it and forget B and put a number. When you divide 4 by 4, what do you get? 1. So when you divide B by B, you get 1. Anything divided by itself, your answer is 1, right? So I'm just giving you the understanding of why this is like this, because sometimes as it gets more complicated, you would need to remember that. So same thing, A divided by A gives me 1. The reason why I can put the 1 there and I can put it there and I can say cancel and get 1. But when I take that 1 and I put it here in front of C, it's the same thing as just C, right? So I don't need to put that 1. So we can just go ahead and say we cancel. What would be the answer if I did? Oh, so let me actually do one more example before I ask you to do one. Let's say I have A squared B cubed C over A to the 5, B to the 4, C to the 3. Now, in this case, what you would do is that the same way how I explained to you how to create these powers, you can actually split them up in the same way, right? So you have one of two options. You can either write out each of these letters. So you can do A by B by B by B by C. And you can put that over. I will have to write out 5 A's. I'm not going to do all that, but I'm just explaining that's what you can do. But the easier thing to do would be if you are, whenever you're dividing, is the same thing as subtracting the powers. There are 2 rules that you need to know. The first is, let's say I have A squared multiplied by A to the 3. Anytime I have the same letter and I'm multiplying, I add the powers. So these will give me A to the 5. But if I am dividing, I have to take away the powers. So if I have A to the 3 divided by A to the 2, I will subtract those powers and my answer will be A to the what? To the 1. Correct? So you can use these rules. Let me move those from there. We can use these rules to do this question that we have here. All I will tell you is when you subtract, whichever letter, whichever term has the most number, has the highest number, your answer should go there. So let me actually change this a little bit. Let me change this one here to be 6 to explain what I mean. So we don't have the time to sit down and do that. If you choose in your exam to do that just to make sure, that's your choice, but it's not really necessary. But what you can do here, these 2 here, remember this line tells me here that we are dividing. And I know dividing means I subtract the powers. So I'm going to subtract 2 and 5. However, the bigger number is at the bottom. So when I subtract that 2 from 5 and get 3, A to be 3, where do you think it should go? At the top or at the bottom? At the bottom. So my answer here will be A to the 3 at the bottom. Now I'm going to do the B's. Again, we're dividing, which means we subtract powers. We will take away the 6 and the 4 and get 2. Where should my answer go for the B's? At the top. C's, we do not see any power there for the C's. No power means it's actually raised to the power 1, but we don't need to write it. Remember that these things mean, if I have, for instance, C to the 3, that means C by C by C. So if I have C to the 1, that is the same thing as just C. So if you see C alone, it's C to the 1, but we don't have a need to write it because it's just one of them, right? Now, I'm going to do the same thing, I'm going to subtract. When I subtract my 1 and my 3, I'm going to get C to the 2. Where do I put it, the top or the bottom? Bottom. And I don't need to put CT1, I will just, sorry, CT2. And that is your answer. Okay? So can you try this one for me? Let me use different letters. Let me try using an M. M to the 3rd. Try that one. Okay, so you should have done the M's by now. Can you tell me if the M's will be to the bottom or the top? Bottom, and it'll be M to the what? 3, correct? And the top will be N to the, sorry, bottom or the top? Bottom. What do you think goes at the top? Can you leave it like that? 1. Why? Remember we said that when we are canceling, we're really dividing. And when we divide these letters and they move, then what we're really doing is dividing them by each other and getting 1. So what would go at the top would be 1. That's the reason why I explained that before. So if you're left with nothing at the top, it's 1. All right, we're almost to.
Ms. Ford, excuse me, could you repeat it, please?
Oh, I explained that when you're dividing the same letter, what you're really doing is dividing it by itself. And when you divide something by itself, you get 1. So if you cancel here, so let's say, let me show you from here. If I'm doing the ends and I'm canceling, that's really what I'm doing, I'm canceling. We are saying that we're subtracting because we're using powers, but really what we're doing is that we're canceling this with this. And when I cancel, when I divide a letter by itself, I'm really getting 1. So that's how I get this 1 on top of here, because this N, both the N and the M end up going down to the bottom. So at the top, we will just have 1. So anytime you are ending up in a position like we were just now, where you realize both of your answers go to the bottom or become the denominator and there's nothing at the top, you should have a 1 at the top. Because you really cancel the letter by itself and your result was 1.
Okay, thank you.
I'm just going to show you one last thing, which is a combination of what we have done so far. Okay, so I'm just going to show you how we will work out a question like this. And you need to combine both of the last two things that we did. You are going to start first by multiplying across, and then you're going to divide afterwards. So what you would do here, I know I can see here I have two A's, so that will give me a square. Then I have a B and a C. Remember, we just join these all together for multiplication. The bottom, I have an A, I have a B, and I have two C's, so those will become C squared. The last thing you would have to do at this point is to cancel top and bottom or divide, as we said, using the same things about the powers. Here, I have two A's at the top, one at the bottom. When I subtract, I'll get one A, and it will go at the top or the bottom? The top. My B's, will I be left with any B's? Yes or no? No, because when I count, they're both the same power. And then the C's, when I subtract them, I'll be left with one, and it will go to the bottom. That would be my answer. All right, it is 6 o'clock. That is it for today. Thank you very much for listening. And that will be it for this week. Your practical, as I said, and your tutorials will start next week. This lecture will be recorded, and I will post it for those of you who are here. It will automatically be posted for those who are online. But I'll post it for those who are here so you can go and watch over. Just remember, like I said, next lecture, I will not necessarily be able to give you time to try examples in class. All right, because you need to move a little bit faster. So thank you for coming, and enjoy the rest of your evening.
Excuse me, ma'am. I have a quick question. Where would we be able to find our tutorial questions for the first tutorial class?
They'll be posted online. They haven't been posted as yet, but I will post them probably by tomorrow.
Okay, thank you very much.
I'm sorry, I came in late. Are all the tutorials online as well?
All tutorials are online.
Okay. And the practicals have to be in person?
The practicals are set up in the same way as this lecture. Some persons will be online, and some persons, I believe, will be face-to-face. It depends on what you chose.
Okay, so I chose Friday. Would that be online?
You have go back on COL, CSOL, and check and see if it should say whether it was online or not. I'm not sure. I'm not the person doing the practicals. But
Okay.
I have a question. So if my practical, I have the same practical as Shelly on Friday afternoon. Can I opt to do it online instead of under the tent?
yes, it will be under the tent. If you want to do it online, you will have to deregister from that one. It might not make as much of a difference, but you can ask the tutorial leader. His name is Julian Roach. You can email him, julian.roach@kpill, and just tell him you want to switch, and then see if you can make the switch with admin. See if you can still do it at this point. I'm not sure if you can, but just see if you can.
Okay, but definitely.
Do you have
if
any idea on the status of overrides?
Pardon me? Sorry, I had two questions. One at a time. I didn't hear you.
I was asking about overrides.
You're asking about override? Oh, so, right. People have been, well, not people, I think admin was telling you for some reason to ask the lecturers for overrides, but they disabled that feature for us. We can't manually add you to a course anymore. The only thing I can do is take your email and email you the information that's on e-learning until the override is approved. Right? So the person who was online who was asking, is that the same thing you were asking?
No, I was still asking about the Friday class. So definitely if you have the practical listed as tent, you have to turn up, and you can't do it online unless you request the change from the tutor.
Yes, that's correct, because the link for the Zoom is only posted for those who have registered online.
Okay, thank you.
No problem.
Okay,
A
add in my
question, Miss
email
Ford.
address.
Hello?
Pardon
Hello?
me? Again?
Yes, question. What you just said in terms of if you didn't register for the online practical, right? And some of us, like for myself, I work and I have to literally ask my boss a favor to leave work, go to UE, 1 to the 10, 12 to 1, and still return to work. Is there a way that we could get exempted from, at least going
Sorry,
to the...
this person who's speaking, I can't actually understand you very well. Can you send me an email? I will respond.
Yes, no problem. Okay, cool.
It's CSAT Maths, and I got a 3, but Kate Math is a mixture of calculus, statistics, and fundamentals. So, as a user, I have to email the program to switch it to the Zoom class. Yeah, you have to go on learn this program. But you will have to wait to override, if they have to do it, if they take away. So you would just have to speak to them. Okay. And tell them that you want to, you're kind of interested. Yeah, I want to switch this class or the online. To online. Oh, okay. I thought you meant to talk. No. So you did integration now? Kate. This is student 1 or 2? Or you this only one I have. Shantae class.
Register for the classes, right? It has one class is for 10 to 6, which is this one here on Tuesday, and the other one is 6:10 to. This one is the lecture, and this is going to be tutorial. But now you're saying that the other one, I heard the other stuff